Hello guys, welcome to today's class. So we'll be looking at a new topic. We'll be looking at binomial theorem. Now in binomial theorem is a very interesting topic because it talks about how we can expand values that are summed up together and then being raised to a particular power or exponent. Now what do I mean in layman terms? I just mean that when we sum up two particular values, be it unknown values, and then we raise them up to a particular power, that is to a particular power, to a particular binomial exponent, and then we are asked to actually expand this. In most cases, we only have these issues when we are expanding unknown values that are summed up together and are raised to a particular index. Now, when we want to expand them, how do we go about it? What processes do we take to make it easier? Now, the binomial expansion is very easy. Now we'll be looking at some cases where we look at how to actually do our basic expansion and what it entails. Now we'll be familiar with cases where we have a situation like this, where we have a particular a plus b raised to a particular power 2, and then we have to expand this. By normal standards, the first thing we do from our normal basic expansion, we know that we're supposed to have our a plus b. We'll be representing our a plus b, since this square means a plus b times a plus b. Then we'll be expanding in such a way that we'll be taking the first value here to multiply both of them. The same thing with this one to multiply both of them. They will have a times a square, a times b ab, b times a ab, and then b times b square. Summing this up together and collecting like terms, we have a square plus 2ab plus b square. Now, by normal standards, you know the coefficients in this case. You know the coefficient here is 1. The coefficient here is 2. The coefficient here is also 1. Now, all these coefficients that we have here are known as what we call the binomial coefficients. Now, these binomial coefficients are very important in the sense that in cases when we cannot actually expand in this manner, we need our binomial coefficients, as that is the foundation of our expansion. That is the foundation of our expansion. That is what we can actually use to derive our expansion, even if we are not to go by our basic expansion methods. Now, it should be noted that there are other methods that we actually use to expand, because it is very easy for us to expand when we have a case of maybe a raised to a power 2. That is very easy to expand, that we can just easily replicate and multiply. But in the case where we have powers that are larger than 2, 3, 4, we have powers like raised to power 25, raised to power, in fact, negative powers, fractional powers. How do we now expand those sort of algebraic expressions? Now, the way to go is we have two processes that we actually use to actually go through this. The very first process is known as the Pascal triangle, and the second process is known as the combination method. That is here, combination, from our idea of permutation and combination. So in the next class, we'll be looking at how we can actually use our Pascal triangle to expand and solve questions based on binomial theorem. See you next class.